Hi guys, welcome back. We are right in the middle of our amazing procedurally generated roof railing system, so we are just where we left off in the last video. I've saved my Houdini file, we're ready to continue on. So the next problem we need to overcome is we want to have uprights on this railing system. So there's a couple of steps we need to do. We can utilize, and I'm just going to move them over to that side just so I've got a bit of space to work here. We're going to make use of this carve node here. So before we generate the outline, the frame outline, we're going to take this carve here and we're going to use this as a basis for our uprights on our on the railing system. So what we're going to do is we're going to put down a line SOP. Okay, and there it is all the way down there. So this is going to be our sort of the starting point for our uprights, and we'll have control over the height of them, and we're going to use our super sweep node so we get all our UVs and everything sorted out. So with our base railing curve established, I'm going to hold down Alt and take a copy of that carve, and that in turn will carve it again. So if I put the display flag on the one above it, and hopefully you can see that in the stream, that it's going to offset the curve again, because obviously we don't want to have uprights right to the very end. We want them to be inset ever so slightly. So we're going to just put a little bit of an offset in there, and again we could expose these parameters and make them tweakable by the end user. So after that carve node, again it's our old friend the resample node. It's getting lots of use. I'm going to turn on point display so we can see what that's given us. And this again is another parameter we'll expose. It's how many upright bars we want to copy onto the railing system. Okay, so with that I'm going to add some point normals because we know we're going to need them in order to copy the correct way. So we're going to assign some normals with @n, and we use that set function that we've used before just to specify a normal direction for all of them. Okay, and then we're going to copy to points. And the primitive we want to copy is that line that we've just created, and the points are the points that we've just generated. Okay, so there we go. There are our uprights on our curve. Obviously you can tweak the height as you see fit. And what we'll do now is we'll grab a copy of this grid here that we've used to outline. We'll just hold down Alt and click that across for us, and we're going to drop down our super useful super sweep node, hook that up, and the profile goes in there, and obviously the grid is in the wrong orientation, so we can just find the right one. There we go, and it's inverted, so on our super sweep we can just put the opposite of that. Okay, and we're just going to make some changes to the values on the grid just to make them square, and then use the value ladder just to shrink them down a little bit. Okay, so they're going to be our uprights, and if we turn on our display UVs, we can just tweak the UVs just to make sure they're nice and even. It's probably a bit too small to see, but we'll get something. Just give it a bit of a tweak until they start to look square. So you can kind of see as they pass by. You want them to be square so that you know that any image that you provide to it will be the same as you've designed it. So the next step is we need to manipulate our railing system so that it sits on top of the upright sections to give it a look that we want. So with that I'm going to template the uprights, and I'm going to come down here and work on this frame section. So we can put down a transform node on the frame section. And what we can do is we can reference the top of the frame using another expression, a Houdini expression, and that's the bounding box expression. All objects in Houdini have a bounding box which describes their extents x, y, and z. So what we can do is we can tell our frame to position itself at the maximum of the bounding box of this object. Okay, and again, we'll go through it, I'll step through it, but I will type it out initially and then we'll discuss what is going on with the expression. So in the transform node of the frame, we're going to type bounding box or bbox, and be careful, it is bbox, it's not box or bb box, it's bbox. And then we're going to provide it, as you can see here, it requires a surface node, so it requires us to reference this super sweep here, and then a type, and then it says it can be xmin, ymin, zmin, etc. So the node that we're interested in is super sweep v22. Make sure you pick the right one from that list. Close out the quote marks, and the second parameter of this is dy size, and close that off. Okay, so as you can see, that has moved the frame up, but because of the way we've got it configured, the center of this object is in the middle of it. So we can fix that in a couple of ways. We can, in our expression, we could subtract half of the size of this object. So we could say minus, and then in brackets we can say $size y divided by 2. So that will move us down half. Yeah. So again, just let me open this up in an expression editor. And this is what I find. I'm not a coder by any means, so this is all kind of new to me as well at one point. But what I'm finding is that the more of these, the greater understanding that you have of these little expressions, it becomes really, really powerful and enables you to do things and connect things up in ways that make procedural modeling make a lot of sense. So what we've done here is, let's take a look at the expression bbox. And it's just saying it returns bounding box information for a surface node. And remember, a bounding box it's just telling you the extents in x, y, and z. So we're interested in the value of the y size, so how big it is in y. And it asks for a surface node, and that's the node that we're interested in looking at, and then a type. And the type can be any one of those, so you could get the xmin, ymin, zmin, etc, etc. Okay, so that's that. Size y is again just a local variable for the transform node, and that just references the size in y of the input geometry. So we've taken the size y and divided it by 2 to subtract half from it, and that will make it sit nicely on top of that. So I hope that's clear. What we're going to do now is we're going to merge these two streams together. So we've got a frame system with all our with all the UVs working, and in theory now we could go back to our original line node up at the top here, and if we change the value of the line, as you can see, our frame is now locked to it. Okay, so we can sort of tweak, we can expose this parameter to make lots of different variations. We've got control over how many railing posts are available to us, and we've also got an overall control of the actual size of the railing. So as you can see, we've managed to generate quite a bit of complexity and be able to generate quite a lot of variation. You know, in quite a few, and in quite don't want to say simple, but you know, we've given the end user plenty of options for tweaking, all the while with the main consideration that the asset has to have UV coordinates, so that the 3D artist doesn't have to worry about having to go away and redo UVs. So I think in that respect we're doing okay with this. And don't forget, with it being a procedural asset, all these parameters can be tweaked and changed. So if you want to import, or if you want to change the shape and size of these railings, you've got that control. Also, this grid down here, we can tweak the size and shape of that. So we've got a lot of control over the overall look of this asset. And that's one of the great things about working procedurally as well, is that you can have lots and lots of control over the look. So let's see where we are. I'm just going to turn that off. What I'm going to do now is just quickly before we end this video, I'm going to just go through and highlight some of the nodes that I want the end user to be able to manipulate. And the way I like to do that is I just like to color code the nodes in the network view. So over the network view, I'm going to press C to bring up my color picker, and I'm going to go through and check which nodes I want the end user to be able to use. So this carve here is sort of the overall size of the railing, and we want the user to be able to access that, so I'm going to color code that yellow. This carve gives us how wide the uprights extend to. As you can see, all the way to 1 is right on the end. So I'm going to give the end user access to that. The resample node here, this value is going to dictate how many railings are present, which again is quite useful, again, to be able to create lots of richness and variety. So we're going to give the user access to that. We want the user to be able to dictate how high or how short the railing system will be. So that could be quite a useful parameter to have. So we'll color code that yellow. And if you wanted to, you could expose this parameter as well, so you can have control over how thick those uprights are. I suppose you could expose the other grid parameter as well, so you could set like a really thick or a really thin type of grid. Okay, so you could expose them, and with that I think we're done. I'm going to turn off these display UVs on our super sweep nodes, and I'm going to jump up a level and see where we are with our railing system. So I'm just going to temporarily merge it into our master merge at the bottom here and press on the display flag, and there we go. We've got a neat little procedural railing system with lots and lots of parameters that we can tweak around with and create pretty much infinite variation, safe in the knowledge that our UV coordinates are going to be updating, and there's no way the artist can sort of break the system. And with that, in the next lesson, what we're going to do is we're going to look at implementing a system whereby we can populate this roof with random props. So I will see you in the next video. Thank you very much.